So welcome to the EPRG course. So I'll wait for a couple of seconds to allow everybody to join in, and then I will start the course, today's lecture, correct? Okay, so let me start. Okay, so I'll stop the video and I'll start on the lecture. Okay, so the course is about advanced programming, as you know, and the language that we will use, the programming language we will use is Python, correct? And you have already done a course in Haskell. So we will, in the first lecture, have to say very little about Haskell, and we'll start on Python instead, but I'll just start by saying how they are different. But before that, let me discuss the evaluation scheme. So the programming assignments will be worth 50% of the grade. There'll be several quizzes which will be worth 20% or so, and there'll be an end sem of 30%, correct? There will be no mid sem. There'll be a bunch of TAs. So TAs, there'll be 3 to 4 TAs, and you must have got information about this course from the Moodle page, correct? The link and so on. Am I correct?
Yes, sir. Okay.
So, there was no problem in joining that. I mean, I automatically joined all of you. So if, yeah, correct. So that's one thing. So all information about the course will be communicated via the Moodle page. So keep checking the Moodle page for various things, including the assignments and the quizzes. I have to decide how to give. I will plan it out soon. And the submission is via Moodle. Yeah, one more thing is that the lectures are being recorded, as you know, and I will put them up in Moodle itself. A link to the, I'll put it up on YouTube with a link in Moodle, correct? So any questions about this?
Sir, just if you can create a playlist and share the link of the playlist, that would be even better, I think, on YouTube. Like create a playlist on YouTube.
Create a playlist on YouTube. Okay, I'll try to do that. Let me say. So you are saying create playlist. This is just for my this thing. So okay, fine. I will try to do that.
Thank you.
Okay. Then are there any other questions?
Sir, not a question, but like the course was not visible in my dashboard on Moodle. Like I had to manually search for the course in the course list to search for it. Like I'm not enrolled in that course, I think.
You are a first year student, correct?
Yes. Yeah.
That's strange. So send me email. Whenever you have such an issue, just drop me an email. Correct?
Okay.
Okay. Is this issue common with others also?
Yes, sir.
Okay. So,
So I think the course has been listed as a future course. Like there should be some point in the future when it becomes active. I'll try to check the date when it's.
I set the date as today, 25th. Maybe that's why. Anyway, send me.
It's starting from 26th, so maybe it's showing in the dashboard where it's future. It starts from tomorrow, is what it's showing.
Oh, is it? I see.
So after tomorrow, it should be just pop into
Okay.
the right place, I think.
Okay. So I thought I started it from today, but anyway, maybe there is some this thing. Yeah, I think I created it twice. First time I deleted the thing that I was creating, and then the second time I might not have saved the correct option. Correct. So, so any more questions about this? Okay. So one thing which I would like to emphasize is that copying, whether in exams and most certainly in the assignments, will not be tolerated. So if you are caught copying, you will get 0 the first time, whether you are at the receiving end of the copying or at the I mean, whether you copy or you are being copied from, you will get 0 uniformly. And second time, you might have to drop the course. Correct. So I'll be very strict about it. Correct. So please do not try to cheat. And certainly, if you have done the assignment yourself, do not hand it out to anybody. Correct. So in the past, this has happened and many good students have had to suffer because of this. And I don't want this to happen to anyone. Correct? Are you with me?
Sir, after the assignment is submitted, the deadline is over. Can we share each other the codes?
So why would you want to do that?
Actually, to solve one problem, one can
you can discuss,
find out a way
but don't
of
share. You can discuss. Discussion is fine. But coding, whatever code you write is private to you. Do not share it.
Okay, sir.
Okay. Okay. So you can tell the other person if you want after the assignment is submitted how you attempted it and so on. But what's the use of handing over your code to them? They don't gain anything because it's mighty difficult to decipher code rather than to understand just the algorithm. So, so I would not advise doing that. Correct?
So are we allowed to discuss and come up with algorithms together for assignments?
For assignments, formally, I cannot prevent you from doing that. And to some extent, it is healthy to discuss. But I mean, certainly coding codes you should not share.
Okay,
Your actual
sir.
code you should not share. Correct?
Yes, sir.
Okay. So that said, by the way, you can see my screen, huh?
Yes.
Yes,
Okay.
sir.
Okay. So let me write this down. No copying will be tolerated. Okay. Okay. That said, let's start on the course itself. Correct. So, so all of you have done the Haskell course, correct?
Yes, sir.
Okay, good. So, so in Haskell is a functional programming language. So Haskell is a functional programming language, and the definitions are inductive definitions. Correct. So, so you write an inductive definition of things, and basically you declare. So, and it's also declarative. So you declare what you want to compute, correct? And not how you compute it, correct? So for example, if you want to, from scratch, if you want to do x plus y, correct? And you have the primitive increment or plus one available, then how would you define it? You would define it inductively. You would say x plus 0 is equal to x, and x plus some number, which is y plus 1, is what you would get if you take the successor of x plus y, correct? So this is the kind of definition you do in Haskell, correct? Am I correct?
Yes, sir.
Okay. On the other hand, if you were to do it in Python, you would prescribe the way to do it, correct? Not derive it from inductive definitions and so on. So you would have to add 92 plus 63. You would say you add the units digits, or let's say, let's change this to, I don't know, something which has a carry. So you do, you add 8 plus 3, you generate a carry, 9 plus 1, 10, plus 1, 16. So you describe how to first add the units place. If there's a carry, carry it to the tens place, add the tens digits together, and so on, correct? So I'm not prescribing a formal definition for addition here, but you can come up with such a definition. If I give you an n-bit number or an n-digit number A and an n-digit number B, you can write an algorithm that can do this, correct? In terms of the digits and so on, correct? So you actually describe how to compute the answer, correct? So so in particular, the way would involve naming, carrying, so calling this A, calling this B, and thinking of them as names, correct? So names play an important part in Python, correct? What are names? They are often called variables in other languages, correct? So named values play an important part in Python. So in Python, so in some of you might already know C and languages like that. So you have variables and you have values. In Python, they are called, you have a name, say A, and this has a value, say 98, correct? And you can also have the value may be an integer, or maybe a list, or maybe some object, correct? So we will come to that later. But just to illustrate a simple algorithm to compute something, let's do a very basic and naive implementation of GCD, correct? So you want to compute GCD of two numbers, m and n, correct? So what is a naive way to do that? So what is GCD? It is the greatest common divisor of m and n. M and n are positive integers. How would you compute it? So you would, the naive approach would involve find the divisors of m, correct? And store them in a list. What is a list? We will say later, but intuitively it's just a list of objects. So here it's a list of numbers, whatever intuitively you mean by a list, correct? Similarly, you will find the divisors of n and store them in a list. And here we make a tacit assumption that the numbers are stored in an increasing order. Okay, so for convenience, let's make that assumption.
We can just check the elements of the first list that are dividing. That would be just a better GCD.
Yes. So we are doing the absolute naive-most algorithm for this.
Okay.
We are not thinking about any optimization. Correct?
Okay.
This is definitely a very inefficient way of doing things. But this is just to illustrate how you would write an algorithm in Python. Correct? So, so once you have these lists, then you find the intersection of common divisors and then return the largest of the common divisors. Correct? So now we will see how to do this naive algorithm in more detail. Correct? So how do you find divisors of n? Correct? So we have to, so this is what is called a subroutine, correct? Or a function, correct? And today we will not speak too much about how to code this function in Python. I mean, what are the commands, what is the syntax and so on. We'll just focus on, we'll just write pseudocode, correct? So, so how would you find the divisors of n? Correct? So divisors of a number a, how would you find? Correct? So this is a function you would like to write. Correct? This finds the one second. You would, I'm writing comments like this, preceded by a hash function. That's how you write them in Python, though we are just writing pseudocode. So divisors of a, this returns a list of divisors of a in increasing order. Correct? So how would you write such a thing? So you would say for each d in 1, 2, ... a, correct? So you look at all the numbers which are smaller than d, correct? So smaller than a, and you check if d divides a, then add d to the list. So the divisor list. But what is the divisor list? In the beginning, there was no divisor list, so we have to initialize it. We say divisor list is the empty list, correct? And here, when we say add d to the divisor list, we mean we add at the end. So another way to write it more succinctly is to say append d to the divisor list, correct? And at the end of the thing, you just return divisor list. Correct? So this is pseudocode for finding the divisors of A. Do you agree with me?
Yes, sir.
Okay. Now, how would you find the intersection of two lists? How would you write the intersection of two lists? So recall we have done this part, and this is automatically done because divisors list of whatever we do for M, we can do for N. We are passing, instead of A, we can pass M as a parameter. Instead of A, we can pass N as a parameter, and we get these two. So now we have to find the intersection of both divisor lists. Both lists of, tell me.
So I don't know, could this work? Like we check the first element of one of the lists and check whether it is equal to the smallest element of the second list. And we do that till it becomes greater.
Correct. So in effect, you are saying, suppose we represent the lists. Let's discuss how to do this. So you have these two lists, A list and B list, and you have an index into each one of them. So you initialize your index to I here and J here, correct? And now you increment, so I equal to Z, so there's 0 and J is also 0. So these are both lists, correct? Now you want to check whether something is common, correct? No, so this is the 0 index, not value 0. So it contains some value, correct? So if the values are the same, you add it to the list, the intersection list, the common list, correct? You transfer these two to copy this here and increment the 3 pointers I, J, and K, correct? And if you find that the number here, so at any point of time you are somewhere, you're pointing here, this is your I, this is your J, which are not necessarily equal. You check whether the number A list I is smaller than or greater than B list J. If they are equal, you transfer it to the I list, correct? And if they are not equal, suppose A list I is less than B list J, then you know that the number A list I has no way of being common because they are sorted in increasing order. A list I cannot occur in this B list ever again, correct? There's no chance of it appearing because all the numbers are greater than B list J. So you can safely ignore the number A list I and increment I, correct? Are you with me?
Yes, sir.
So you do this till you reach the end of one of the lists or both the lists. At least one of the lists, if you reach the end, then you are done. There cannot be any further common factors, correct? So we could try to write the subroutine for this. So how would we do this? We can either do that or leave it for a future this thing. Let's try doing it, correct? So so you first set I is equal to J equal to 0, and then while I is less than length of A list, and J is less than length of A list minus 1, because the length is because I and J start from 0 and the length is and the length is goes up till includes the 0, correct? So meaning
Excuse me, sir. Shouldn't it be length of A list not -1 because you've taken less than sign?
That's also true. That's a good point. Yeah. So while I is less than length of A list and J is length of B list, correct? The same way, correct? If A list I equal to B list J, this equal to means I'm comparing the two elements and they are equal, correct? Then and I also put K equal to 0, correct? I say I list K is equal to A list I.
So instead of tracking K, we can just append the numbers to another list.
Very good. So we could just say I list dot append A list I, correct? And in fact, this is better in some sense because this is correct, more correct in Python because otherwise you would, yeah. So,
Sir, to append something to the list, we need to initialize it first, right?
yes, yes. So we would have to initialize I list is equal to the empty list. And instead of this, so I'm not giving you exact Python code, but it can be converted to Python code. This is just pseudocode, correct? So append A list I, and what do you do? I is equal to I plus 1, J equal to J plus 1, correct? Else, so else, so I'm just writing, okay, let me write it. Else if notice that this can be changed to elif in Python, but let's stick with the original thing. Else if what is it? So else if A list I is less than B list J, correct? Then what do? You just change, you just increment I. That means you are ignoring the ith element and moving on. Else finally J equal to J plus 1, correct? Correct? And now you know that I list is the, so I claim that if you return I list at this point, after having gone through this loop, correct? Then the value of I list will be the intersection of these two lists. Do you agree?
Yes, sir.
Correct? Because, and why will this procedure always terminate? Because at every step we are incrementing either I or J by 1 and possibly both of them by 1. I and J are finite, so I plus J is finite, and that is decreasing by, I plus J is decreasing by 2 or by 1, correct? So at some point of time, it would become, so 1 of I and J would become 0, correct? I plus J is uniformly decreasing, I and J are monotonically non-increasing. So at some point, one of them will become equal to the length of the A list, correct? Am I making sense? Did I say monotonically decreasing? I should have said, basically I'm saying one of the I and J will reach the end of the list, correct? So this will terminate. Now, now what is the, so returning the last element of the list, that is the other thing, correct? Return the largest of the common divisors, correct? So how would you do that? the naive-most way of doing that is to go through the list and return the last element. Correct? But of course, that's wasteful, and you can just simply return the last element by looking at. So there are ways in Python to either find the length of a list and return the length minus 1th element, or you can just return L minus 1, I list minus 1. Correct? So for list L, L minus 1 is the last element. So you can return the largest of the common divisors. The divisors come in increasing order, so you know that returning the last of the divisors is sufficient. Correct? Are you with me?
For list, it still takes linear time, right? With the length.
With the length, depends on what is the internal data structure to store the list.
Yes, the normal list, and for array, it would probably be.
For array, it will be a constant, but in Python, probably lists are also stored as either as hash tables or as, I don't know, as binary search trees or some such.
Oh.
So that is hidden from us. What is the implementation, correct? And for the sake of Python, we assume that all these operations are constant time operations. L minus 1 is a constant time operation. In any case, you can store the length of a list very easily in your data structure, correct? So, yeah. So, and how, so there's a difference between arrays and lists. That is true. And if you have to traverse the entire list to get to the end, it would take linear time. That is also true. Correct? So let me try to convert this divisors thing into a Python function. Correct? So how would I do that? Let me copy and put it at the end, and then indicate how to do this. So I would add the keyword def before divisors to make it the definition of a function. Correct? So now divisors is a function. It takes an argument a, and you put a colon as a delimiter. This % remains, it's just a comment. Then I put a tab stop here or blanks here, and initialize this divisor list as this. And now I have to replace this by an actual for loop. So how do I do that? I say, so I will remove this, or let me erase this. That's better. For each d in 1 through a. So I will say for d in range 1 comma a plus 1 colon. Correct? So this runs from 1 through a. A plus 1 is 1 more than so this gives the successor of this gives the number at which we do not consider in our range, which is this is the first number not in the range. Correct? And instead of so I should have commented it off. That would have been better, but let us nevertheless. So let me comment this. So here I write if a percentage d equal to 0, So this computes the mod of it computes A mod D, correct? So so if A modulo D equal to is congruent to 0, if A is congruent to 0 modulo D, correct? I should write it properly. Basically, whether A is divisible by D or not, correct? Then, so I don't write an explicit then, I write a colon, then append D to the divisor list. So divisor list dot append D, correct? I could also have written this as divisor list is equal to divisor list plus D, correct? And there is a subtle but distinct difference between the two, which we will go into in more detail next time. But the idea is here divisor list is changed in this piece of code. Divisor list itself changes, while here I create a new no, one second. So yeah, so here I create a new see, that might not be correct, but anyway, so there is a distinction between the two. Yeah, okay, so yeah, this is, I think, the right hand side here is a new list that consists of divisor list plus D, correct? So, and then you change the value to this, correct? Okay, so having said that, you return this divisor list, correct? So, and now how would you define your GCD? So you would, let's do that. You take so I will write def this thing instead of the this, I write M list is equal to divisors of M. Similarly, I write this is getting to this thing, so let me just should I anyway N list is equal to divisors of N, and find the intersection F of both the lists of divisors. So so we say I list is equal to intersection M list and N list, and then return I list. Remember, I list returns the value, and this is the, so for example, when we wrote this divisor list was returned, And when you say mlist is equal to divisors, the returned value is kept in mlist. Correct? Are you with me?
Yes, sir.
Hello?
Yes, sir.
Okay. So this would find the GCD, and I will not go into the Python implementation on intersection. It is or do you want me to do it? I could do it, but it's basically just the syntactic thing. You can write def here, this. So you would replace this by len of a list. J is less than len of B list. And if A list I is now it's almost this one will be changed to elif. That is short for else if, correct? And I should write it below. And one thing which I must emphasize is that in Python, the syntax, the tabbing determines the scope rules. By that I mean that what am I writing? Sorry. Yeah. So here, notice that I left this blank here, and this determines that this I equal to I plus 1 is in the scope of this elif. Similarly, these statements are in the scope of this if. We do not have explicit delimiters like, of course, there are delimiters like colon, but there is no brackets and so on in parentheses in Python like C to do this for this purpose. So in C, you would write open braces to group a series of statements and so on. All that is not there in Python. Everything is done via, all this is done via explicit tabbing. So how indented your code is determines which part will be executed when. Correct? Am I clear? So I should say I list minus 1. Sorry, I made a mistake. I don't return I list. I return the last element of I list. Correct? And if you want to optimize, there are many ways to optimize this function. Of course, many of you would know Euclid's algorithm, which does it much more efficiently. But even in this code, we are storing the numbers in increasing order of divisors, correct? If instead we stored the numbers in decreasing order of divisors, then the first common divisor will tell you the largest common divisor is what you want, correct? Do you agree?
Yes, sir.
So you could write a loop in which I mean, you could combine it and make it much more efficient. Okay, so I will not go into that optimization right now, but it should be clear to you how to do it, correct? So so today's class is necessarily short, and we will get into it was just a warm up to Python, correct? And to this imperative way of programming. And we will see more of it next time. So do you have questions? Any questions for me?
Sir, not like exactly related to what we've done till now, but is there a textbook you're going to be following for the course?
So there is going to be no formal textbook for the course, but part of the reason being that I do not want too much overlap with algorithms, correct? With the course algorithm, which you'll do next semester, correct? So, but if you want to refer to a book for something, then this book by Das Gupta, Papa Dimitriou, and Wazirani is a good reference.
Focus. Thank you.
Okay, but there is no formal textbook. More questions?
So would it help if while calculating the A list or B list, we calculated till A by 2 because
By A by 2. Why A by 2?
I mean,
Yes, it would help. Yes, but
yeah, because I mean, how many devices do we get? I mean, the largest.
maybe the last divisor cannot be more than A by 2.
Yeah,
That's true.
yes, that's what I mean.
Yes, that's true. So there are many optimizations possible, like I said, and this was not to emphasize on optimizations, but on how to write programs and how to translate them in Python, correct? And we have not yet talked about Python syntax formally. We will do that next time. There's just, like I said, a warm up to the actual code, correct? Correct? So more questions?
Sir,
Yeah.
so will we discuss loops and all in the following classes? Or
Yes, yes, we will. We will.
Okay.
Definitely.
Yeah.
Yeah. More questions?
So will you talk about those things like data structures and all those things? My concepts
yes.
about those are not clear.
Yes. We will talk
thank
about
you.
Google data structures. Yeah. Yes.
It might be like a bit out of question, out of question, but can we like we had lazy evaluation in Haskell. We don't have that in Python. Can we like simulate that?
Sorry, I couldn't understand the question. Could you repeat that, please?
We had lazy evaluation in Haskell.
Oh, lazy evaluation in Haskell.
Yes. So we don't have that in Python. So can we like simulate it in some sort of?
So, firstly, lazy evaluation is, so how do you define lazy evaluation?
Like any structure, any object will be used only when it is required. Like when it is called by some recursion.
Correct.
Otherwise, it won't be implemented.
That is true even here, correct? I mean, you will not develop. So like I said, this range, for example, a very trivial example is this range thing, correct? For D in range 1, a plus 1, correct? So if you were to evaluate this formally, you would convert this into a list consisting of 1 through a, correct?
Yes.
But even in Python, you don't do it unless you explicitly say for D in list of range of 1, a plus 1. So you do not expand this into a list. So there is some notion of laziness even here.
Okay, sir.
Correct? Okay. More questions?
So could you please, yeah. So what is the name of the book that you recommended?
Name of the book. They together have just this one book.
I mean,
It's got
the one
algorithm.
I'm getting is algorithm and data structures.
Algorithms and data structures probably, yeah.
Okay.
They have this one book together, all three of them together. This is a unique key. Yeah. Yeah. More questions? If not, then let's conclude today's lecture here. And I will put up this thing in the playlist, like you say. Okay. And I will share the playlist. Correct? Okay. So thanks, guys. Bye.
Thank you, sir.
Thank you, sir.
Thank you.
Thank you, sir.
Thank you, sir.
Thank you.
Thank you, sir.
Thank you, sir.
Thanks. You don't have to thank me individually. Thanks. Yeah.